We are on a collision course in mutual descent towards our neighboring large galaxy, Andromeda, also a system of several 100 billion stars. The Andromeda galaxy was the one that brought to light the fact that the universe and creation itself didn't revolve around us. It proved that the Milky Way isn't the only galaxy on Earth and that we might just be a speck in the greater universe. Over the past century, we've learned a lot about Andromeda, but most of that information has been from Earth. Now, with access to instruments like the James Webb Space Telescope, things are a lot different. It turns out that Andromeda isn't what we thought it was. Data from the James Webb Telescope has shocked the entire industry. Join us as we bring you all the details on the truth about the Andromeda galaxy and the shocking discoveries that have changed what we knew for the past century. Just over a century ago, the Milky Way was commonly thought of as a band of faint, wispy, whitish light stretching across the night sky. This perception was influenced by the limited technology of the time, which prevented astronomers from discerning individual stars within the Milky Way. People held various beliefs about the Milky Way, often associating it with the center of all creation, where the celestial and terrestrial spheres met. Galileo Galilei, an Italian astronomer, revolutionized our understanding of the Milky Way in the early 17th century. Using his newly developed telescope, he made groundbreaking observations that challenged the prevailing Aristotelian cosmology. He discovered that the Milky Way was not just a diffused light band, but a massive collection of individual stars, planets, and other celestial objects. The Milky Way galaxy, the nearest galaxy to us, is the Andromeda galaxy, and we think there are about 100 billion galaxies in the visible universe. So, believe it or not, that means we can actually count the number of stars in the visible universe. Through his observations, Galileo demonstrated that the Milky Way was not at the center of the universe as previously believed, but instead a vast expanse of stars scattered throughout space. In 1750, English astronomer Thomas Wright proposed a new hypothesis in his work, an original theory or new hypothesis of the universe. According to Wright's speculation, the Milky Way was not a random distribution of stars in space but a completely flat layer of stars. He also suggested that a portion of this vast structure was our own solar system. While Wright's hypothesis was a step forward in understanding the structure of the Milky Way, it was still limited by the observational technology available at that time. They all still believed that the Milky Way was all there was to it, and considering the limitations, that's not surprising. But astronomy made major leaps by the early 1800s, and by the early 1900s, things were changing fast. If you've made it this far into the video, you clearly share our passion for exploring the mysteries of the universe and uncovering the truths behind these groundbreaking discoveries. We dive deep into these topics regularly, bringing you the latest updates from space science, astronomy, and beyond. If that's something you're excited about too, make sure to hit that subscribe button and turn on notifications, so you never miss out on our upcoming videos. We've got so much more to explore together, and your support helps us keep bringing you content that makes the wonders of the universe more accessible. In the 1920s, Edwin Hubble, an American astronomer, made a transformative discovery using the 100-inch Hooker telescope at Mount Wilson Observatory. Hubble observed distant nebulae beyond the Milky Way. Through the observations and analysis of these objects, he showed that they weren't actually part of the Milky Way but were entirely separate galaxies, each containing billions of stars. One of the closest of these galaxies was the Andromeda galaxy. The Andromeda galaxy, also known as M31, has a rich history of observations dating back centuries. One of the earliest known records of this celestial object can be traced back to the 10th century when the Persian astronomer Abd al-Rahman al-Sufi described it as a small cloud. In star charts from that period, it was labeled as the little cloud. That might have to do with the fact that when you examine it from Earth, it does seem like it has a faint cloud all around it. The significance of these observations lies in the fact that al-Sufi was able to identify this distant cosmic entity without the help of telescopic instruments. Relying solely on his keen eyesight and observations, he was able to do this because Andromeda is one of the few galaxies in the universe visible from Earth's surface without any special instruments. All you really need is to know exactly where to look, and you'll see it right there in the open sky. Sure, you can't go into much detail, but you can still see that something other than the usual stars is there. It wasn't until 1612 that a more detailed description of the Andromeda galaxy based on telescopic observations was provided by Simon Marius. His work laid the foundation for future astronomers to study this massive cosmic structure. Later, in 1764, the renowned French astronomer Charles Messier catalogued the Andromeda galaxy as M31 in his well-known Messier catalogue, mistakenly attributing its discovery to Simon Marius, unaware of Al-Sufi's earlier work. But that doesn't mean Messier didn't have a major hand in putting Andromeda on the map. For almost 100 years after this, astronomers worldwide tried to understand more and more about this mysterious galaxy, each adding to the last one's findings. A significant leap in understanding the nature of the Andromeda galaxy occurred in 1864 when English astronomer William Huggins made a groundbreaking observation. He studied the spectrum of Andromeda and noticed that it was different from that of a typical gaseous nebula. This paved the way for the world to really understand Andromeda for what it is. While it's vast, the Andromeda galaxy has a mass estimated to be between 1 and 2 trillion times that of our Sun. It's a colossal cosmic structure that happens to live relatively close to us in the vastness of space. In all the research conducted so far, scientists believe that Andromeda is about 10 billion years old, making it quite ancient in cosmic terms. Its age hints at a long and intricate history of formation and evolution. One intriguing aspect of Andromeda's origin is the hypothesis that it came into being through the merging of several smaller protogalaxies. This suggests that over billions of years, smaller galactic entities gradually came together under the force of gravity to form the majestic Andromeda galaxy we see today. Such galactic mergers are common occurrences in the cosmos, shaping the growth and structure of galaxies. However, it all happens so slowly that you can't see it until major progress has been made. For a long time, astronomers thought Andromeda was significantly more massive than our Milky Way galaxy. From an objective point of view, a mistake like this could easily be made because we are inside our own galaxy, and seeing Andromeda from Earth makes it look so large that you'd think nothing could come close to its size. But that's not the case. Recent research has led to a re-evaluation of these beliefs. New findings have led scientists to somewhat reduce their estimate of Andromeda's mass while simultaneously increasing the mass attributed to our Milky Way. As a result, the current understanding is that the masses of these two cosmic giants are much closer than previously thought. If you were to be in Andromeda and looked at Earth, you'd see just as massive of a galaxy. This perspective helps us realize how colossal the Milky Way is too. The Andromeda galaxy's physical dimensions, though, what astronomers totally agree on. It stretches farther than our own Milky Way, with an impressive diameter of about 220,000 light-years, surpassing the Milky Way's estimated diameter of roughly 100,000 to 175,000 light-years. This vast size makes Andromeda a truly significant cosmic entity, occupying a large region in space. This revised perspective also highlights the complexities of accurately measuring the mass of galaxies. Galaxies are immense systems, and their mass is intricately linked to the distribution and movements of stars, gas, dust, and dark matter within them. Pinpointing these values precisely requires sophisticated observational techniques and meticulous analysis, which is why this reality is just coming to light now. By far, one of the most fascinating features of the Andromeda galaxy is its active galactic nucleus, or AGN, a highly energetic region at the center of the galaxy. It is characterized by intense emissions across various wavelengths, from radio waves to X-rays. AGNs are powered by the presence of a supermassive black hole at the heart of the galaxy. When astronomers observe the AGN using advanced telescopes like the Hubble Space Telescope, they notice something interesting. The AGN appears to have 2 points of concentration, meaning there are 2 distinct regions where light and other forms of radiation emanate more intensely than in the surrounding areas. The brighter concentration is slightly off the true galactic center, and within this area lies the supermassive black hole. The mass of this black hole is estimated to be between 1.1 to 2.3 times 10 to the power of 8 solar masses, meaning it weighs approximately 110 to 230 million times more than our Sun. Supermassive black holes are common in the centers of galaxies, including our Milky Way, and they play a crucial role in the evolution and dynamics of galaxies. When matter, such as gas and stars, gets too close to a supermassive black hole, it forms an accretion disk around it, which heats up and emits intense radiation. This is why the AGN is highly luminous. In the heart of Andromeda, the supermassive black hole exerts a powerful gravitational pull on surrounding stars. As these stars orbit the black hole, they follow elliptical paths similar to how planets orbit the Sun. At the closest point in their orbits, called perihelion, the stars experience the strongest gravitational forces, causing them to move at their highest speeds. This results in stars bunching up and releasing energy in the form of radiation, including visible light, creating the brighter point of concentration that astronomers observe. The second point of concentration, which is dimmer, is located at the true center of the galaxy. This phenomenon has puzzled astronomers for some time, and ongoing research aims to understand the dynamics behind it.